Okay, so can you hear me? Hello? Yeah, welcome once again to our training on blockchain programming. So, last week we discussed a general overview about blockchain development, the story about how everything came to being, and then how we're able to. Okay, can you hear me? So, okay, that's good. So last week we were talking about blockchain evolution. Can you see my presentation? So I was just giving a detail about our introduction to blockchain, and then trying to make it as simple and relatable to everyone on board, either you have a programming background or not. Last week I was just making sure that you have a basic idea of how everything works. Good morning. How everything works, and then okay. So this today we will go a step further. So I'm going to cover module 2, 3, 4. Yes. So let me start from module 4. I just want to give you an overview. Let me see whether I can get to 5. No, I won't get to 5. I'll stop at 4. So let me start from that 4. So it's today that we'll be introducing ourselves. I will be introducing you to the tools that we'll be using. So there are several tools if you want to build software on the blockchain. So the first tool is your mind. I want to get you to understand some concept in programming. So I want you to understand concepts like blocks, chains, and nodes. And I also want you to understand concepts like immutability, and also get you to understand programming in like programming as it is. Like I don't know if you have a background programming background there, maybe you are in computer science or you have done any course in programming, any language. You can just say yes on the chat there, on the comment there, so I can have an overview of or those people that I'm discussing with. Know how we present the concept. I'll go know how far I can go with the concept of programming. So the overview of today's lecture is just introducing you to um, programming and the tools that you will need to write smart contracts or blockchain softwares. So um, that would be let's start from this module module 2. Yeah. Okay, so I can only see one person saying yes. Okay. So for the project and everything, that will be after this week lecture before we can actually discuss anything about programming or anything about programming projects or anything like that. So I just want you to understand how to write or use the basic tools available for you to develop a program software on the network, on the blockchain networks. So let's start with the concept of blocks. So when we are talking about blocks, what we mean is that we mean that um, okay, the last week we talked about um, blockchain as what's it called, a ledger. So we were talking about blockchain as a ledger, and then the basic understanding of a ledger is a place where we record transactions. And I move forward that okay, if you don't have programming experience, just say no. Just say no. I just want to know how many people here don't? I just want to have an idea of people that don't have blockchain programming. But this lecture is going to be fair to everyone. I'm not going to be too technical, and then I'm not going to be too just. I'm just going to make it balanced. So let me drop some things to the group. I will drop. Uh, okay, okay. I think most people here don't do not understand the program. So let me just go straight to. If you are here last week, you realize that I was talking about blockchain in terms of ledger. So we are all familiar with ledger now. So, but let's talk about this ledger in terms of a storage, a place that will store documents. Okay, okay. So I don't know. Okay, it's back. So where we stopped last week was describing the ledger in terms of the blockchain, and then okay, 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 that's good. So and also we are talking about how Bitcoin made use of the decentralized ledger, software-based ledger, to be able to authenticate transactions and then solve the problem of double spending. Then how Ethereum network was able to leverage on that existing technology and build a Turing complete machine on top of that concept of ledger, whereby instead of recording transactions on the network, we can also perform computations on the network. So the concept of computation was by von Neumann that year that he was able to discover a stored computer program. So before programs are, I've started introducing you to computer programs. So before is the programs are only written in with electrical circuits. So, but John von Neumann and his team, they were able to understand the concept called the stored computer program. So the logic, let's say, let me give you an instance now. Do you notice that on your laptop you can click, you can use software to shut down your laptop instead of shutting down with your hardware? So there are two ways of shutting down your machine. You can shut it down by pressing the add button on on your computer, pressing it down to shut down. And you can also press shutdown. You could have experienced this before, either on your phone or you can press shutdown on your software in the operating system there, and the computer will also shut down. Either way, either software or hardware, you can shut it down. So that is what we're able to obtain with stored instruction program. So basically, what happened is that the concept of or everything that you can perform with hardware, you can also perform with software. So I'm just trying to take you down the memory lane so you can understand that there's a way we can virtualize all these hardware components like RAM, like clock speed, and then you can share different hardware components in form of software. So those are the things that were abstracted away in the Ethereum virtual machine. So, if you have heard about Ethereum virtual machine before, and if you have not heard about it before, this is the first time. I just want to introduce you to Ethereum virtual machine. So let me go straight. I think I put it down there. Okay. Maybe I missed to talk about it. Okay, let me just talk about Ethereum virtual machine. So you can just take note of that. Ethereum virtual machine is a virtual computer built on the blockchain. So instead of hardware now, it's software. The whole computer is a software, but it's a computer, but it's a software computer. So I'm just giving you an instance of an operation, a simple operation that you could have done before that you are like using the hardware to switch off your machine and also using software to switch it off at the same time. The same operation is being done. So now, when you are talking about a virtual computer or a virtual machine, you are talking about a full system like your laptop now that can run a program. So don't forget that this course is all about programming. But you can't talk about programming without talking about computer. And the type of computer that you are programming here is not directly the hardware computer. You are programming the virtual computer, which is uh, in our case here, we are using a virtual machine. So a virtual machine was designed 2015. Yeah, started 2015. It has evolved over time. But the concept are still simple. Every other blockchain systems that you can deploy a program on have the same concept. What they are doing is that they are using a stored instruction set to abstract away hardware concepts on the network. So now, there's still a type of computer that we are still going to introduce each other to after this course, close to the end, which is the ICP, Internet Computer ICP. That's a type of blockchain that is more uh, locally oriented. It's more close to like the abstraction is more the abstract in a way that they don't make it look as if it is blockchain. They make it look as if it's a normal computer. So now there's the type of computer that you'll be using every time. It's called server. Is a server. So what happened with a server is that a server is a kind of machine that you can distribute, you can run it, you can share it. So when I'm talking about a server, I'm talking about a server in form of an hardware. So you could have seen all these giant machines that are in Microsoft data centers or AWS data centers. So when people used to have this, especially I've noticed this between people that are not into computing, they used to have a wrong concept talking about the cloud. So they will say that all our data and everything we are doing is in the cloud. Uh, Cloud computing is a concept that originated from distributed computing, whereby it's not like maybe the cloud, the atmospheric cloud, like you know it. It is just like we are talking about a network of computers, especially servers that are in different geolocations. So we can have like for now there are millions of machines that are powering the internet, especially the Ethereum virtual machine. There are some machines that are in different locations in Europe, in North America, in Africa. They are just distributed. But these servers are distributed all over the place so that people can share their resources. So anytime that you deploy a smart contract, what you are doing is that anytime you deploy a program on the blockchain or there's a crypto on the blockchain, what you are doing is that you write a software and that software was shared among different servers on the network. So now, the reason why I'm giving a basic understanding of different servers is because there's still another layer after, like there's a fundamental layer which is the hardware. This the computer is real, is a hardware computer, but that computer is a type of computer. It's not just like your laptop, but you can make your laptop into server, but it's not like your laptop. This is a kind of computer that is used to run heavy computations and heavy or large data centers. So now these computers have more capacity to share. Like these are the computers that are solving our problems that we use to share our network and then computations. They are basically powering the internet. So this type of computers now they are running a type of software inside of them. The software they are running is called server software. So this type of software are what is going to execute our programs. So now there are three layers of abstraction there. So, if you are not aware of abstraction, the abstraction is something called ability. Abstraction is a way is a form of communication that if I just want to give you an example of abstraction, a practical example of abstraction. Abstraction is you can make a corner and then it will get to Lagos or get to US or anywhere in the world. It's true abstraction because that core, you don't need to know everything that is going on in the whole system. You just you need to know some simple part of the system. So the concept of abstraction is still going to be detailed later in the programming course explanations. When I'm writing some code, I'll be telling you. So what abstraction is able to solve is that it is giving us ability to separate concerns and not have full knowledge of the whole system. So you don't really know what's going on and how your core get to reach someone at the other end of the continent. You don't know how that happened. And you don't need to know about everything because of the concept of abstraction. Abstraction is how we're able to minimize complexity and deal with things. So as a programmer, you always deal with abstraction every time. So now I'm just trying to explain and break down the abstractions that you are going to be dealing with as you are dealing with everything. So you have a hardware. The hardware is running a software. The type of hardware you are talking about is a server. The server is running a software. The software inside the server is also a server software. You understand? They call it a server too because it is responsible for executing some codes that you're going to deploy. Now, in terms of Ethereum virtual machine, Ethereum virtual machine is more of like an operating system. A server is an operating system actually. So sometimes you could have been familiar with Windows operating system. Windows operating system inside Windows operating system, you can run your different apps like your YouTube app, your Telegram app. You know Android operating system now. Android operating system is inside an hardware, which is your phone. But this type of Ethereum virtual machine is an operating system that is running inside servers, and then I could have gotten a chance to show you different servers. So let me see whether I can show my screen. I don't think I can show my. Okay, let me share my screen. Let me share my screen. Um, mm, okay. Mm, okay. So let me try to share my screen. If you can see my screen, just say yes once you can see my screen. Can you see my screen now? I just want to make sure that everything I'm talking about is a visual representation that you can use to relate to. So when I'm now writing Zali, so virtual machine is just like a VM where you notice that you can also deploy what's it called, another operating system inside another operating system. So that's like another layer of abstraction inside of existing operating system. You can also deploy another operating system. Okay, you can only see the slide. So I don't think. Oh, I wish I can share, but I'm already sharing it. Maybe I have to stop the slide before. Okay, I'm trying to get it done. I'm coming. Um, I don't think I don't think I can do it from here. Yeah, I don't know why this is not sharing here. Maybe the admin will help me out. But let me just okay. I think I'm there. Okay, I'm there. Can you see my screen now? Hope you can see my screen. So I want to get you to see data centers, servers. So these are the type of machines that is running on that is powering your. These are the type of machines that are powering your what's it called, your Ethereum networks. So inside these machines, you can see them. Inside these machines, then you can have a different version of like you can deploy any type of program inside of them. So these are the machines that are running, these are the servers. So now let me now go straight to show you the Ethereum virtual machine architecture. EVM architecture. So you can see the abstraction properly. Let me find one that is more simple. I need a simple virtual architecture. Sorry, I want to make this more clear. Okay. So what I'm trying to show you here is a simple what's it called? A simple abstraction of there are more there can be more complicated what's it called? More complicated architecture. But this is like something that you can see, understand, that can describe to you that you have a mental model of. I just want to give you a mental model of everything going on in Ethereum virtual machine architecture. And mind you, it's not only Ethereum virtual machine architecture. There are other architecture in Ethereum in the on the network in blockchain. So, but let's talk about this. So, what happened is that a transaction is happened. This is a transaction. A transaction is in form of a text message that was sent to the network. So, but in this case, every transaction inside Ethereum is not. So that's why when you deploy a smart contract on the network, it will cost. So anytime you send a transaction to the network, you notice that earlier we are talking about blockchain, BTC. BTC is just transaction based ledger, but this time around, Ethereum has built another layer on top of it. That okay, instead of just saying that we are dealing with only transaction, we want to make sure that these transactions are more than just a transaction. They are also executable softwares. So I told you about how a software can also behave like an hardware in a simple model about switch. So when you can switch off your machine by clicking the hardware, you can also switch it off by clicking shutdown. Okay, you look at my screen now. You can screen you can press this shutdown and it will close and it turn your PC off. At the same time, you can do it manually. So now in this concept now, either this transaction enter the network, this is the network, this is the whole network. But remember that I told you earlier, I said uh, the network, the ledger is like a database. So what happened is that there's a program here called the Ethereum virtual machine. It's a software. Let's call it an operating system. So the operating system is just is able to interpret any instruction. This is the interpreter that will interpret. This interpreter has been programmed to interpret every instruction that is sent to it. So the interpreter interprets some byte codes. So you also see some byte codes later on. So anytime you write a program in Solidity, this program is going to be converted to bytecode, and the bytecode is going to be fed into this interpreter, and everything you said that it should be done following the rules and regulation of the Ethereum virtual machine to execute it, and it will be able to keep a state. So this is state DB, state database. You can also store the state outside. You can that's why the data on the network and data that is on the network can also be stored in another machine outside the network. So now this data that is on the network is in form of a software, and this data that is outside the network is also a form of software, but it is like the way you can actually store data inside your operating system and also copy that form of data inside your hard disk, external hard disk. So this is like an external hard disk where you store your data, and this is like the the data that you kept inside your operating system. Now, this is the configuration of the operating system. We have different configuration of the operating system. The way I configured my machine now is different from the way you are configuring your software, your operating system, your own machine, your own computer. And this is context. So context is like just telling us the kind of situation. Now, this is it. So for every transaction that comes on the Ethereum virtual machine, it is being executed by people on the network. And those people on the network are going to be paid for executing the transactions the same way it was done on blockchain, on BTC, on Bitcoin. But in this case now, it is more than just a financial transaction. It is a full computer software. It's a computer program. So that computer program may be a financial transaction. It may be anything. It may be it may be a full software. It may be a game. We are aware of all these Solana games that are bubbling the whole place, and there are also games on the Ethereum virtual machine. And these things can also be NFT. So software is very sweet. There's So I'm sorry, the network. Please, where do you miss me? Please, where do you miss me? Okay, okay. Now let me just go straight to. I was showing you something. I was talking about some architectural stuff then. Um, so I was trying to share my screen again. I think you can't see my screen yet. So I just want to show you because this thing you'll be interacting with this thing because if you don't have this frame of like if you don't have this knowledge frame like structure if not this knowledge is not structured properly in your mind. My major objective is to make sure that I give you a very strong foundation that you can lay on. So if you have a very strong foundation of how everything works in detail, then after this course, you can still continue on your own and have a very strong learning on your own. Even though those courses may not go too deep and give you this foundation very well. So now, uh, hope you can see the architecture that I'm showing you here. So I'm just talking about this architecture as the network just disconnected everyone. So now the message can be anything. The message is a software, a form of transaction that enters the network, and the people are going to solve it. They are going to use their hardware, their servers to perform the computation, to run the program and to store the program. They run it and they store it for you. But all those stores are going to cost Ether or some GUI. So all those Ethereum are going to be like the amount of money that they pay those people that are running distributed servers to just execute it. Now, there are different models for that, but I think for now, for writing a program and deploying it on the network, this is good for you to understand. So when I mean what I mean by network, everyone, if you are not aware of what a network is like, let's say social network now, it's a connection between different people. But in this time, it's not between different people, it's between different machines, different computers, different servers, different softwares. So those softwares are or computers are those things that make the decisions whether this transaction is successful, whether this transaction is not successful, whether this software is meeting some standards of software that can be deployed on the television machine or not. So all these servers are running a copy of a television machine on themselves, inside themselves, and they are coordinating and collaborating using a concept called consensus. So, but we are not going too far to that. Now, let's talk about the 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 objective why the main objective why I'm showing all these architectures. Let me go back to my slide. Now, the main objective is that I want to I want to teach you how to write some programs on the blockchain, and you will need some tools to do that. So, if you want to build a smart contract, or you want to build a crypto coin, or you want to build an NFT, uh, you can always think about them. Starting with this, you just let's say let's say I don't know anything now. I I don't know anything about programming. I don't know anything about computers. Okay, I don't know anything about programming, but the little I know, I have a computer, I have a phone. I've been hearing about crypto. I don't know anything about all these things, but I want to build a computer. I want to build a smart contract. I want to build a software that can run on the blockchain. So what do I do? What I will do is that I will go and check out with an expert, whether I go online or check some tutorials or YouTube or check any other things. But those people will not be able to give me some solid grand foundation on everything. But there's a way you deal with not deal like as a programmer, you are to solve a problem, but there's one very important problem that you need to solve before solving any other problem, which is the abstraction problem. So you want to know how to deal with what you don't know. That's the main issue here with every programmer. So as a programmer, you are a knowledge worker, and every time you are trying to solve problems that either you have the full knowledge of, or you want to capture the knowledge for it. So basically, what you are going to do, I just want to give you a step by step procedure. If you want to take your notes, you can take your notes. So as I now that I just want to estimate my knowledge as someone that did not know anything about programming or blockchain. So what I do is that I will come to something like this, like what you are listening to now. So what I'm giving to you now today is like I'm giving you the abstraction. I'm giving you the knowledge frame about the whole eagle bird eye on the whole thing. I just want to give you like kind of have a knowledge frame of how everything work under the hood. Then immediately you have an incomplete knowledge of everything, how everything work under the hood, but at least you have a frame, a mind frame, a frame of mind of how everything works. So now you now go and get your hands dirty. You want to like practice some things and test some things out. So once you want to practice all these things and test them out, you will need some tools to guide you and you will need some tools to be useful. And this stuff that these tools, what is very useful about these tools is that you want something that will give you feedback instantly. You want to engage in such a way that uh, that diagram I shared earlier, someone is asking why what's it called? Is called uh, Ethereum virtual machine simple architecture of Ethereum virtual machine. I can share it on the group later on. It's a simple architecture of what is going on inside the Ethereum virtual machine. So now let me go back to what I'm saying. Anytime you just want something that you can do, you want to do something, but you want to measure your error back. How much are you getting it, or how much are you not getting it? So you need a way that you can quickly start writing a program, simple as possible, but you can get the feedback as soon as possible. So one of the tools that is useful is called the Ethereum Remix IDE. So I just want to give you an introduction to Remix IDE now. Remix ID is a tool that you can use to write and deploy smart contracts on simulated Ethereum virtual machine and also real Ethereum virtual machine. But in this introduction, we will be talking about simulated Ethereum virtual machine. So the assignment here will be like there's a documentation for the Remix ID, there's a documentation for Solidity, there's some standard documentation for Solidity and Remix ID, and there's a standard documentation for the Ethereum virtual machine itself. So if you go straight to it and you read through and there's anything you don't understand, you can always send it to the group or share with any of the admins to share with me. But I just want you to just make sure that you consume enough knowledge so that you can gain the most from everything I'm discussing. Because after this lecture, we are going to be deeply technical a bit. We are going to be more technical. So there will be, it should be very useful for you to just make sure that you are able to prepare yourself ahead by going to Remix ID. So I will go to all these documents, all these sites now. You can also try to check them out on your own. I will be sharing my screen as I want to just share my screen now. Let me share my screen. Please let me share my screen. I don't think I don't control sharing screen. So please I want to share my screen. Um okay. Is anyone in charge of this? Let me share my screen. All right. Now let me go straight to please I want to share my screen. So remix ID. So hope you can see my screen. Can you see my screen now? Uh, please, how can I share my screen here? Please, I don't know. I don't think I'm the one in control of sharing my screen myself. So please, if the admin can help me out. Mm, okay.
Hello, Damilola, can you hear me?
I can hear you. I can hear you, sir.
Which of the screen do you want
I want to
me to?
just the one I was using, the one I was sharing earlier. The one I was sharing earlier. The one,
This
this
one?
is my slide. This one, the one
This
back.
one?
Okay, exactly. This is the one I want to share. Yes. Thank you. Okay, so go to remix.ethereum.org. Can you see it? Remix.ethereum.org. If you are there, just say yes. So once you click remix.ethereum.org, you are going to be presented with a development environment. So this is the simplest and easiest tool to quickly deploy smart contracts, interact with smart contracts, get data, deploy data, share data, use it to understand what you don't know about the network and have a practical understanding of everything you're doing. So it's still loading here. Please, if you are there, quickly say yes on the please. I'll be waiting for everyone to that's the link. Documentation. Let me get to it. Okay, remix doc. So remix ID. This is redux.io. So this is the official documentation for Remix. So everything that you need to know about this Remix 2 is here. Everything. So it's an assignment for you to go quickly go through them. So go through it and then have a understanding about how everything works. So this is like welcome to Remix documentation. This means used for the entire journey for smart contract developers by users of every knowledge level. So you can use Remix as what's it called a starter and an expert too. So ID is part of Remix project. So what happened is that I just want to quickly go through all these things. So navigation, this is navigation you can default to, but I'll give you more details. So, but this site, I just want you to make sure. Please, if you are at the documentation, let me see. You just say doc yes, DEOC yes, doc yes. Quickly, give me doc yes here on the comments on the comments section. If you are on the documentation, because the documentation is as important as the remix too. Because if you don't know how to use the remix, if you don't have the documentation, you won't be able to know how to use the remix properly and more professionally. So I don't know why my own remix is still loading here. But please, are you on the docs? Oh, you are seeing with the first slide. Ah, okay. Docs, yes. Okay, you're on the docs already. Okay, okay. Please make sure that you get to capture the docs and save it and read through everything because it will give you a full detail about like everything you want to do because it's useful to have deployed real world smart contract remix that are very professional. It's very good to. It's very easier to use if you're able to use remix. It will save you a lot of headache from all these existing tools that require you to have too much programming knowledge. So, if, for as a beginner, I recommend remix because to give you some. So I think this one is still loading up, and then before the remix is done loading, I think I can just continue with my explanation about smart contracts. Okay, so people are on the docs. So have you loaded your own remix ID? Ah, I don't know. The network is a bit terrible over here, but the remix ID is just loading up. So I think they have upgraded it to receive explanation from AI. So they have actually improved it over time. So are you on the remix ID already? Yeah, that's very sweet. You can write a smart contract on your mobile phone if you are using Remix. That's one of the sweet things about it. So you just load it on your browser and then you can compile, you can push to GitHub, you can do all dev operations on it. It's very, very good too. So since my own is not loading on time, I wish I can just open it and click some things and show you some things about it, but I will still wait a bit. So, but before it's loaded, let me just quickly give you an explanation. Unknown error happened. What happened? So, what I'm saying is that with Remix, you can run JavaScript codes, you can run Solidity codes, you can run Viper codes. This is Viper computer compiler too, and you can add some plugins to it. You can also use it to write documentation about your code. You can use it to run and test your Solidity programs. You can interact with your Solidity programs. It's very easy for me because most of the time, anytime you write a program like that, you will want to write a test to it. So Remix has a way to automatically write tests for you. It's very, very, very beautiful thing. And you can also combine some plugins that will allow you to deploy on other blockchains network. It's not only for Ethereum alone. And you can also what's it called? Verify contract codes there, source codes and byte codes. You can verify them there. You can verify on a task scan. Every time you write a program, you have to verify it for it to go live. There's a lot of things you can do with Remix. These are plugins that once you attach it to Remix, you can do a lot of stuff. So these are Stacknet. These are like kind of compiler to write contracts for this network, Cairo, and several other networks too. So this is a cryptographic plugin, you know, proof of stake, ZK synchronization is a cryptographic tool. So this tool is useful for this for identity verification. This is so this I just went to the I'm waiting for my remix to load. Welcome. This is okay. So it's because I'm just loading this remix for the first time. I intentionally want to load it for the first time so that there won't be any kind of maybe the way it's loading on my own computer is not the way it's loading on your own computer. And then I want you to there's it's still booting up. So once it's booted, I will show you all the functionalities and how you can use it. I will deploy a smart contract automatically here before we now go into the details of the smart contract and show you how to use this Phoenix more efficiently and professionally. Okay. Yes, please, if the admin can help us, I don't think I can paste anything from this end, please. So you are saying that you want to have access to the link to the remix and to the documentation of the remix. So there's also one thing here. This thing is they have updated this thing too much that it's having a time loading. Let me reload it. So there's another one thing, which is the solidity documentation. So Solidity documentation is the library is a body of knowledge for everyone that is aspiring to be a Solidity developer. So anything that is written in Solidity is the Bible of Solidity. Everything that is written in Solidity, this thing tracks Solidity down to the core and to different versions of Solidity. So as you can see here, hope you are there. Hope you are at the Solidity lang. So the current version is version 0.8.26. Hope you are there. If you are at the Solidity documentation, please. First is the doc, second the remix itself. Yeah, the remix itself is remix.ethereum.org. This is the link to the remix itself. The documentation is remix-ide.redocs.io. They are different links entirely. And the Solidity documentation is solidity docs.soliditylang.org. This is the link. Now, it's possible we are going to send all these things to the Telegram channel later on after the training. So there's another documentation I want you to go through because I really want you to have time to prepare yourself for that next week because I will do a bit of technical say. I'm already stepping into a technical and I really, really want you to get 100% of everything I'm doing so that there won't be anybody that is lagging behind. That's why I'm dropping all these things. So if you're able to take your time and read all these things, you are going to enjoy me 1,000% during the period of my. I will be too fast in the because I have only an hour. So I'll be very fast in implementation but I want you to be up to speed. That's why I'm making preparing a groundwork for you. So this solidity, there's another thing I want you to check out, which is Ethers.js. Ethers.js is a JavaScript library. This is documentation for Ethers.js too. It's a JavaScript library that you use to interact use it to interact with smart contracts on the network. You can use it to create a wallet. You can use to create a wallet, retrieve wallet, like interact with several wallets automatically as a programmer. Um you can use it to also interact with any other smart contract that is Ethereum virtual machine type of architecture. Don't forget that Ethers.js uh, Okay, please, can you hear me now? Can you hear me now? Okay, thank you. I'm back again. So please, can you just where do you lost me? Can you remind me where you lost me on the comments? Um, okay, just remind me where you lost me so that I can just. I was on Ethers.js sharing about Ethers.js, and then I don't really know exactly when the disconnection happened. So where do you lost me? Where do you lost me exactly? Can you see my screen? So to just continue, I was trying to make sure that I am giving chance to those people that can run with this, so that by the time I start executing next week, um, okay, I think it's time for us to. Okay, please, where do you lost with IGS? So tools and its applications. Okay, yeah. So I was talking about. So let me quickly explain these things that I am highlighting. Let me explain it from here to down. So when you want to, if anybody want to read here now, so immediately you will be able to remember everything I talked about here. I just want to help you so that you won't be the only one just dealing with all these things. So I'll just give you. So I've been talking about keep your. So these are the features of Ethers.js, and I told you that Ethers.js is library aims to be a complete and compact library for interacting with the Ethereum network. So now, so what you can do with Ethers.js is that you can automatically write a program that will create a private key and save the key. And that means you are basically creating a wallet on the Ethereum network. So you can import the wallet and do all the wallet operations that you can perform on all these decentralized wallets, like Trust Wallet, all these things. You can do it, and you can make all these mnemonics to appear in four key phrase memory that you used to save when you create a wallet. You remember all those phrases that you save when you create a wallet in MetaMask or all these wallets that are existing now. You can do it at years. So these are called HT wallets. Now, meta classes create JavaScript objects from any contract API. So what happens is that you can also abstract uh, a JavaScript object from an existing smart contract that is already on the network, so you can effectively interact with the objects. So because these things we are going to talk about, we are still going to do something like that, whereby we deploy a smart contract, then we want to interact with the smart contract. This can be done with Ethers.js. So now connect the Ethereum nodes like JSON, RPC, Infura, Etherscan, Academy, Cloudflare, and MetaMask. So these are existing Ethereum nodes that you want to either you want to sign your smart contract on them like Etherscan, you want to verify and sign your smart contract on them, or you want to generate a signing key on JSON or Infura. You want to make sure that your smart contract is recognized on the network as a valid and verified smart contract that can execute uh, properly on the network. So ENS, so these are the Ethereum naming systems. So like the DNS we have on a normal system or normal internet computer that you are using it to, Ethereum naming systems now. You could have seen some email or website address that are saying that Damola Olasende or Damola processor dot ether.io. So those are the Ethereum naming systems. So they are also tying in whereby the data can be compressed to this, and then you can also compress data to this. You can compress data to send to the network in order to reduce your gas fee, and you can also download data from the Ethereum and uncompress it. So the compression and uncompression, you see. So this you can like this is an order of like this is the order of like 1, 2, 3. So you can 3 times compression, 3x. This is big. That's another feature. Another thing is that you can complete functionality. You can have a complete functionality for all Ethereum needs. So a complete functionality for anything Ethereum network or Ethereum virtual machine. You can also use it for all these Ethereum virtual machine compatible systems like there are other Ethereum version like Polygon now. Polygon is similar to Ethereum. It's using Ethereum virtual machine compatible, and several other networks like that. So large collection of test cases which are maintained and added. So there are more source codes that you can use that already existing on the network. Immediately you're able to understand this thing. If you have the full knowledge of this thing, there are many source codes that you can use that is already tested and used. So fully TypeScript ready, you can use TypeScript. TypeScript is another version of JavaScript. So and it's MIT license. That means that it's just an open source license that It's not like maybe you use this tool and they sue your company for using it, or you are into any litigation. So now this is talking about getting started, how to install it, how to import, and then how to use it on all these things. These are the full documentation on how a developer can use it. So Ethereum basic. So Ethereum has an event. And in JavaScript, I'll still tell you about events, and they can log all the things that are going on the network. These are gas, how you deal with gas and gas limits. So you can set gas limits for your own smart contract, or for the amount of gas you want to spend on deploying a smart contract on the network. So it's also security. You can defend against server side attacks, and you can encrypt your keys, and you can derive a new key on the network. So you can connect with all these APIs with Ethers.js, all these ones. You can connect with them and create a default APIs for yourself. um, Application programming interface. So these are the kind of API for directly connecting with your Ethereum system. So Ethereum virtual machine account method, blocks method. So you can interact with the blocks, Ethereum blocks. So you can also interact with the Ethereum naming system. These are you can interact with the Ethereum. This is the full Ethereum programming interface. So application programming interface is a way whereby a software interact with another software. So if you want to interact with Ethereum, these are the section that you come to anytime you want to write a functionality that wants to interact with Ethereum or any Ethereum nodes. These are the functionality under it. So uh, you can also talk about signer. You want to sign something on the network. You want to create a wallet. You want to void signal. So contract interaction. So you can interact to contract instance, event, meta class. You can also create a factory of several other contracts, create other instance on existing contracts. You can use it to deploy a smart contract too. You can also use it to retrieve from a smart contract. You can also connect to smart contracts. These are the property methods and events and meta classes too. I'll still give you more details on meta class later. And please feel free to ask any question from me on the group or through any channel that you can ask questions. Once you like, it's not everything I'm talking about on this group that on this call that on this class that is going to be what's it called, you can ask me question on any documentation I just shared with you, either this Ethers.js documentation or the Solidity documentation or the plugin documentation or the remix itself. So let's quickly check out some remix codes. I think they still, I don't think they give us existing codes there again. I thought they used to give us some smart contracts, some default smart contracts before. Okay, let me look for some smart contracts. Okay, this is a template. Let me see whether I can create a template. uh Okay, yeah, this is a template. So by clicking this, I'm able to create a ERC721 token. So what is an ERC721 token? An ERC721 token is a protocol for NFTs and non-fungible tokens. So there's ERC 120 there. Let me show you. So what I'm trying to show you is there's a more details about ERC 71, but I don't have much time. I want to just use this remix before it's gone. So now basically this is remix ID. What is there is that you can create, assuming you can create a new file here and call it either JSON file, HTML file, or JavaScript file, or TypeScript file. You can call it uh, first first smart contract.sol. So this is a Solidity smart contract. So you can copy all the details here. So sorry, this one is compiled automatically. I'm just rushing because my time, I don't have time again. So here now, this let me just give you an example of this. I will still give you more details of, but this is the file explorer. This is the file explorer. You can use it to access files inside this what's it called? Inside this is like, imagine this as like your like your systems folder, that inside this browser you have your codes there. And inside your codes you can create a folder, you can create a file, you can create a folder here. So this is a folder, folder one. So inside this folder you can move stuffs into the folder. Let me just, okay. I don't think you can move stuff. But I'm just showing you that this is like kind of what's it called? A kind of development environment for you to write codes and deploy codes. So the existing codes, due to the template code that this is the home. There's a template code that I use there the other time that I used to write. I quickly use it to deploy to implement uh, a smart contract, NFT, which is a ERC-721. This is an NFT, and this NFT, immediately you compile, you press play to compile. Immediately it compiles, you can see the build. So now there's something here that I want to show you. I don't think it's showing up. Okay, it's showing up now. So anytime you want to look at what is going on the network, you'll be able to click here and listen to transactions on the network. Now, there is another thing here called like search. You can search for files that's inside the IDE. Then this is the Solidity compiler. You can change to different version of compiler here. So, this is, I told you earlier, I was showing you Solidity 0.8 version 0.8.2.0.8.26. So inside this version, now this is the version of Solidity that you are working on. You can quickly reference that version inside this remix here. This is it. And you can reference older versions there. So there are some codes that are older versions. So it's like there are different software versions. And the programming language, the Solidity version. So you can reference them here and select the compiler that you want to use to compile your stuff. Look at this is 0.8.20. So that means that what I'm trying to tell you is that higher version can compile lower, so you can't use lower compiler to compile higher versions of code, but you can use higher version of code to compile lower version of code. But it's not every time that that's the case too. But most of the time you can still run it. Now, let me move fast and show you another thing here. So you can auto compile, whereby anytime you write a code now, it will automatically compile. When it's compiling, you to be showing you some things are rolling. Let me try to see. It is rolling. Look at this. It's compiling. It's showing. It will show green now. Once it's showing this, compilation will be successful. Once you successfully compile, if you check the file here, you realize that this is my first contract. Abi, where's the name? Where's the this my first contract can be deployed. So this is, you will share the name of the contract. Look at my token. This is my token. Immediately I click on it, it's automatically compile. Then once it automatically compile, you go to this deploy and run transactions. So it's, as I said earlier, I said a transaction is a software. Instead of just calling it transaction, it's actually technically a network and it's using media to run it. But it's a full software too. So you can actually go straight to click on this deploy and run. So this is Remix virtual machine, simulated Remix virtual machine. If you want to connect with the real network, you can connect through MetaMask. But these are several simulated virtual machines. There's one in Cancun, there's one in Shanghai, which is Japan, there's one in Paris, there's one in London, there's one in Berlin. These are machines, servers in different locations, as I've said earlier. So these virtual machines are different. So this, if you select the one in London now, in Berlin now, it is loading. This is the address of the one in Berlin, and it is having a simulated 100 hectare. So there's 100 hectare on it. You understand me now? So you can actually quickly deploy. This is like a simulated virtual machine, not the real virtual machine. They call it testnet. Yeah. So in this case now, if you quickly press deploy here, I just want to make sure that I press deploy. You can see that it's not compiling with compiler EVM version. Look at it. I'm very happy with this error. It is not able to compile this and deploy it. Why? Because it's saying that this thing is not compatible. So I don't know what it's saying. It says it's not compatible. Now let me try to go to the code again and change the compiler that I used. This 0.20 here. You can see 0.8.20, 0.8.20. I already said I should automatically compile, so it is still compiling it. So immediately it compiles, I will try to deploy again. It's still compiling. So I think it's done compiling now. I will now go to this place. I want to deploy. Just make sure that you are looking at the name and it's still the same name that is here. Let me click deploy like that. Say that you may not be consciously increase the gas. Okay, this is the gas issue. So now I want to increase the gas limit here to, let's say, compiler. The execution might be thrown to a use the selected environment is not compatible with compiler version. Let me use this environment, the virtual machine here, to compile it again. Let me deploy. So it deployed. So what is going on was that the the network that I choose there, which is the Berlin network, is not ready to execute based on the criteria that I gave it to that I gave to the gas limit. Now, when I now choose this one now, you notice that this is 100 hectare before it has deducted what's it called 100 one. I don't know. It's a fraction of hectare. They call it GWEI, GWEI. So it has deducted some fraction of the token just to execute to deploy my smart contract. So after deploying, you can interact with the smart contract. Look at it. This is my token. This is You can see this is my token. So it's already on the simulated network. So you can paste an address here and send the token to it. You understand me now? You can place an address here and send the token to it. So okay, this is the owner of the contract. I don't want to go too far yet. But this is an application programming, this is an interface that you can use to, like a form on a website that you can put, anytime you want to do a transaction. Yes, let's say you want to send an Ethereum now, an NFT now. So I think my time is up. But let me just round up this one. When you want to send an NFT, what is going on is that you will provide the address of those people you want to send the NFT to, and the ID of the NFT you want to send, and the address will be here. Then you send transact, and it is sent to the person. Transfer from, so it's another function. So this function are default on the Ethereum network. Let me see whether I'm not lost already. Are you see there? Okay. So I think that's the end of the lecture for today. I just want to make sure that you are prepared for next week, because that next week we are going to really dive deep into the programming aspects. Please, I want to remind you that I talked about Ethereum Remix. You can play with it when you get home. And then the remix documentation itself for you to understand how to use it properly. And I talk about Solidity documentation. I also talk about Ethers.js. So these things are what you need to understand. And feel free to ask me questions during the week. I will answer all your questions if the questions are related to everything I've been talking about. It. You understand? So I think we are able to do justice for at least preparing you for next week. So we have just two meetings. So those two meetings we are going to do justice um to the following on my slide. I want to check. I want to present my slides, please. So I want to show you. There's a section inside my slide that is going to be about the solidity itself properly. So we are going to go into solidity one on one, and then so I'm taking it from top down now. I'm not taking it from ground up because if I take it from ground up, there will be a lot of things that you may miss. Um, Please, you can ask the admin where which channel you can ask questions from. I don't really know how the questions are can come across, but you can ask the admins uh, how you can ask questions. So um, yeah, that's it. I'm also on the Telegram group too. You can see Machine Genius. So I'm Machine Genius on the Telegram group. So you can do that directly on my DM as a machine genius. Yeah, machine genius. If you say machine genius, you understand that's me. So what else? What else? What else? Okay. Thank you so much for the time, for the patience to you allowed me to actually go through all this jargon without stressing out or panicking. Thank you so much. But please, I really, really want that next week now. I may use 2 hours because I really want to push a lot of information across to you, and I want you to be prepared for me so that I will be working, I'll be thinking, I'll be working. So I will code, I will debug, I will do a lot of stuff, and then I want you to be interactive as possible. And if there's a need that if that during the day we can open our Telegram channel whereby we can just execute and talk because this is like I want to just lay a very strong, solid foundation that you can build on later on your own and become a successful blockchain developer. Thank you so much. I really appreciate you. Thank you. Bye bye. So you can also contact me on the Telegram group. I'm Machine Genius. So let me share. Let me talk about it. Okay, this is Machine. So that's the writing there. Thank you so much. I really appreciate your time. So this is the link. I'll send this to. I'll send this to the. I'll send this to the group too. This is the architecture, the simple architecture of the Ethereum virtual machine. This is where your codes will be executed. Okay. Thank you so much. So bye bye. Have a nice day. Bye.